the general populace of people who need to be dealing with preserved software data in institutions don't really know or care as much about the difference between what they would consider minute historical or technical things with games. So we decided to start a project called the Game Metadata and Citation Project to essentially create a set of controlled terms for how to describe games in preservation collections, talk about ways to embed correct description of software and games into library metadata standards that already exist, so that people could kind of co-opt them into systems that they already used. And then just provide essential guidance and information for collecting institutions that need to preserve games or preserve software objects. There's also a citation component to the project, which I will not talk about, except to say that that is also a very large issue, in that if you have objects preserved in a collection, the means to cite it or find them again, or even talk about and discuss them in academic writing, is kind of non-existent. There's no standard for citation of software, and we're kind of working on that right now as the project goes on. Maybe I'll be talking about it at some point in the future. Another kind of preservation issue that develops out of the organization of game collections is canonicity. Whenever you're kind of making a decision about what to include or not include in a software collection, you are making a distinction about what's historically important and what's not historically important for the future. So for people who are deciding what they want to or will not be able to study going forward. The problem that this kind of develops that we got into when we were doing the Game Metadata and Citation Project, because we were looking at, like, what game systems exist, what types of things do you need to describe, is that there's an insane number of dedicated video game platforms that have existed over the course of time. Now, this list isn't actually even exhaustive because it doesn't include operating systems and it doesn't include what I would term general computing devices. Most of the things on this list, in fact, pretty much all of the things on this list, were designed to, play games. And when you get into these types of numbers of platforms and things that have existed historically, you kind of need to decide what you're going to include and what you're not going to include. And this gets even hairier when you move into, like, the whole class of computational objects. For instance, you have games that are really popular, like Super Mario Bros. 3, Myst, and Doom, but, those are the ones that were made for the CI-89 graphing calculator, because there's an active CI-89 graphing calculator community. And in my estimation, this is not a canonical version of Doom, but we are making basic assumptions about who programs things where and what versions of things are significant, that then impacts the understanding of games history going forward. Also, in relation to Doom and canonicity, when you try and preserve a game, say you have Doom in your collection or Doom as a preserved object, which Doom are you talking about that you're saving, right? There's many different versions of Doom. You need ways to describe what versions you have in a repository if you are actually, taking the data from a Doom disk and putting it in some sort of digital collection. Or if you just have it physically, you want to have it described in a way that someone knows what type of game they're getting, or what version of the game they're getting. And so the distinctions between the objects that you're dealing with kind of get really messy very quickly when you actually try to put them into practice and put them into game collections and describe them effectively. Other stuff that kind of comes into migration from the more physical end, comes into preservation from the physical end is migration. A lot of the media formats that things have historically been stored on are, kind of obtuse. You have, in this example, SNES, Super Nintendo system, and Sega Genesis cartridges, and on the right, an extractor for the Nintendo Entertainment System. So there's specific hardware that's now designed to get the data off of all of the intricate and multivariate media formats that you'll find in a software collection. Now, this is actually easier for more popular formats. But you have other formats that are less well-known, that are made by popular companies like Nintendo, that are significant historically for interesting reasons. This one is a Nintendo Famicom Disk System floppy disk for a floppy disk addition to the Nintendo Famicom, which is the Nintendo Entertainment System that existed in Japan. And this specific disk is actually the original launch platform for The Legend of Zelda. So if you want to play the original conception of The Legend of Zelda, you play it on the Famicom Disk System, which was released only in Japan. And as an interesting historical note, the reason that Nintendo cartridges had to get a battery backup feature is because they needed to emulate what was already available as on the floppy disk format that existed in Japan. So there's this notion that certain media formats might be esoteric, but they're also kind of significant to specific ideas and narratives in game history. Storage is also a problem, generally in preservation. I'm not going to cover too much here, except that if you have, a physical item, as long as you don't care about the data on it, you can store it pretty effectively because it literally just, goes in a box and goes on a shelf. This is a picture of the Stanford Auxiliary Library 3, File 3 here at Stanford, and there has been some issue organizing for how to put boxes of software that needs to sit inertly in a collection for long periods of time, but the more pressing issue for them is actually getting the data off of the disks first, because if they sit there for too long, the data will actually get corrupted and disappear. If you have these items in a collection that are stored and you describe them and that type of thing, the other kind of preservation challenge is representing them back to a user or an academic or someone who might need them in the future. For physical items that you have an actual physical piece of hardware with, it's not trivial. I won't say it's trivial to set up a Mac and get it running from 1984, but if you have the actual machine and the actual media format that goes into the machine, you can kind of hook it up. You can get back the physical experience of playing it without as much, need for technical wizardry that I'll keep talking about in a second. The problem with having physical items that you're storing and getting back is that you need to do maintenance on physical hardware continuously the entire time you have it, because eventually it'll degrade and go away. And so we, in general preservationist perspectives, tend to kind of say that preserving hardware is going to be a very specialized niche thing, and what you really need to do is get the data off of the physical items and then find a way to represent that data to an end user. One of the more common ways of doing this now for a certain class of items is emulation, in which you write a software program that can interpret the data you have taken off of a physical media and then represent it through some other computational construct. In this case, a browser window for the Internet Arcade, which is one of the more popular online places to look at emulations of games. Now, emulation also has kind of issues itself, specifically due to the lack of it having the same physical instantiation of the original object. This is a picture from the Stella emulator that is emulating. This is kind of an emulation, an emulator doing a physical emulation, so it's kind of a nested thing. On the left side is the display from a modern LCD screen, and on the right is an approximation of what it would look like on an old CRT television. And you can see that this is actually a racing game, and so on the right side, the tires' graphics are designed to blend together based on their expectation that they're being shown on a CRT. So it actually has a tire that is kind of visible. On the left, it looks like kind of some spider monster. And so a lot of people who play games today, even in browser emulation, are essentially wholly unaware of why certain graphical things look the way they do, and it's essentially because there was an expectation on the part of the developers to use the, economy of pixel blending at the time to, kind of save on some graphical processing for other places. Again, with emulation, another problem is that you're not, playing your Nintendo Entertainment System with the little controllers on a television in your living room. You're looking at it in a browser or through your laptop. And embodied interaction that gets left on the floor when you approach representation through emulation in this way. Okay, so essentially preservation challenges for preserving software, preserving games. The top 5 here are kind of the big ones. The next kind of issue with preservation, which is less of a challenge and more of a packet of functions, is the scoping of the preservation activity. So when you look at the history of game objects, general histories of games tend to focus on just commercial, the lineage of commercial objects, right? You have someone develop, in this case, in this collection of things that I put on the screen for reasons that will remain secret until later. You have Pong being developed and put in a bar down the peninsula and then getting translated into a home Pong console, and then Atari makes the Atari. Narrative for how video games developed after that point. But the kind of, I guess, problem that I always have with focusing on pre-assigned significant historical markers in game history is that you essentially start choosing like what valid members there are at Game History Club. Like there's a lot of games that were made from 1978, well, since the commercial game industry existed, and a lot of the preservation practice and a lot of the focus ends up being on things that were, you know, commercially successful and incredibly viable, which in some sense is rightly so because you want to focus on the things that were popular and that are staying in people's imagination. But in working with the collections that I have at Stanford, you find a lot of stuff in historical collections that is kind of just interesting as indicative of the time, or that is trying to do things that are different or what you would think would have been new now but had been actually tried in the past. I always put the Communism into Space box in my presentations for preservation because I just think it's, well, A, it's kind of hilarious, and B, you know, it was made in a specific time and place for a specific reason. And then on the right, you have 3 Mile Island, which is actually not a disaster simulation. It's that has it's this game to, you know, play with the management of a nuclear power plant, which I haven't really encountered again. So there's this whole like swath of activity in the history of games that gets followed up essentially when you like just kind of focus on certain commercially successful platforms and games. And then this kind of bleeds into the actual preservation effort by communities, right? A lot of the more popular systems have a significant amount of dedicated emulation effort by the games community, fueled by this nostalgia for the specific stuff that was commercially popular. And so you end up with this, you know, selection bias towards the history of games and towards the preservation of game objects, you know, based on this activity. Okay. So, getting on to technical history, and what does it add to preservation, what limits does it reveal? When you view preservation through that standard model that I had kind of put up at the beginning, and we have all those different issues with description and I guess quantification of the games. When you start getting into the study of them even more deeply, or like get down to the level, it just ends up getting more complex, not less. For the rest of this talk, I'm going to kind of be positing a model, a like strong-end model of games based on Chris Crawford's Listen, Think, Speak loop. This is an illustration from Steve Swink's book Game Feel. I really recommend checking that book out if you're interested in the, I guess, physicality of expression in games from an engineering perspective. Now, the Listen, Think, Speak loop is a relatively simple model. It basically posits that in any game interactive system, there's a human that is listening, thinking, and speaking to a system that is also listening, thinking, and speaking. So it doesn't have a place of priority or like a hierarchy in the interaction. It's more of just this combined feedback loop. And a lot of the preservation practice that we have right now is kind of focused on preserving the right half of this diagram in hopes that eventually it will inform the left half. That you kind of get all these old objects and preserve them so that you can study their history and reveal something about how the human interaction works. But when you even start kind of positioning this, you know, construct inside like larger historical currents, for this specific example, I'm going to just talk about some technology studies and some development practice history. It starts to kind of complicate our understanding of how to preserve games even more. For instance, if you look just technologically at the objects on this slide, you'll notice that the top left are actually hardware. They're not software. The original Pong machine was a modified television set, modified television hardware. And the Pong home game was a collection of circuits that were not, they don't have source code, right? It's actually a physical construct. Whereas everything else on the slide is actually some variant of a MOS 6502 assembly language encoded machine. Now, this is an important distinction to have, and it also kind of complicates our model when we talk about the standard preservation at the beginning, because some seminal items on this slide already don't fit into this idea that there's a separate software that you have to, maintain, and so you kind of get into a distinction of basically like where to fit in this hardware history, given that now there's a lot of so it doesn't kind of fit into the conventional preservation model that we've organized earlier. Another kind of way that this gets complicated is if you kind of take a granular look at any specific item here, like for instance the NES. This example is motivated by Nathan Altesa's book I Am Error, which I would highly recommend if you're interested in the history of the Nintendo Entertainment System. But if you look at the Nintendo as a classified object, it starts as a family computer in Japan with its attendant Famicom Disk System, and then gets released in the United States as the Nintendo Entertainment System. And it also kind of has a collection of peripherals and other input devices that interact with the game and further complicate our ability to do preservation, because if you're doing emulation, do you want to write a software emulator of Rob? Is that something that you really want to? Rob is a interactive toy that came with one of the original Nintendo systems where you could move little spinning discs to play games. And from some perspectives, it's a very interesting historical object. From others, the preservation of it is basically just putting it on a shelf, and I don't know if you'd want to do some sort of grander software emulation of Rob. But if you go even deeper into the Nintendo, you realize that even though it existed as a singular object, as a basic platform that you would buy, the cartridges and the games themselves actually included essentially these memory management controllers or mappers, which was additional powerful hardware that let you do and express more with the games. So that the graphical capabilities and the sound capabilities of the system actually got significantly augmented over the entire train of its existence. And so this distinction that we have for like generational games or like the NES existing and the Super Nintendo existing actually doesn't really work as well when you kind of look at the train of how games have developed on the system. So this is an example, which I hope this isn't that loud. You got it. Okay, good. So this is Nappy, which is a port of an arcade game from 1983 to the early NES. And its entire design is just a direct emulation of the arcade game that it came from, right? It's not trying to do anything or really exploring anything outside of the confines of the arcade design grammar from which it came. And it's what you get when you get initial early Nintendo games, right? They're coming from a different design. They're coming from a different design paradigm and structure where you have a high score and live and that type of thing. But if you go to the end of the NES's life cycle, after many years of development and many kind of advances in the cartridge technology, you get a game like Range Point, which is one of the last Konami games released for the system, and they only want to use the VRT7 mapper, which gave it much more advanced sound capabilities. And this game is not really an arcade game, right? It's a full-fledged role-playing game that has an orchestrated soundtrack, opens with a very long cutscene, takes hours and hours to complete, and I guess design and aesthetically has a lot more in common with like early Super Nintendo games than early Super Nintendo games than anything else, right? There's this idea that the game generations were really strict boundaries, and if you look technically inside the machine, you see that they've actually kind of advanced much more, I wouldn't say smoothly, but there's kind of a significant amount of advance even within a generational cycle of the expressive capability of a platform. Okay. That's kind of, if you do some deep platform or technical studies, you reveal certain details that you might want to consider for later preservation that would not have otherwise be apparent. Another thing that you can do, which is like what I'm also very interested in, is studies of development practice and how the preservation of objects with this standard idea that you have just the data that you're saving and studying. If you want to really understand how the system